So the 4.3 lecture introduces some right triangle trig, and we should be used to the sine, cosine, and tangent. So we're looking at the SOHCAHTOA, some old horse caught another horse, taking oats away. So we should be familiar with these trig functions. And then the ones over here are cosecant, secant, and cotangent. And the idea here is that all you have to do is flip the original ratio, and notice that the C's don't go with the C's and S's don't go with the S's. So pay attention to those answers. So in the first example, I'm just going to draw an arbitrary triangle. I'm going to put a right triangle there, and they will put theta in one of the angles. Sine is opposite over hypotenuse. So we're going to use our Pythagorean theorem to find the missing side, and you can set up the equation if you like. X squared plus 7 squared is equal to 25 squared. So x will be the square root of 625 minus 49. And if you go over to a calculator, so go over to the calculator, 625 minus 49 leaves us with 576. And if I square root my answer, I get a nice 24. So this will be 24. So the missing side is 24. So now if I do sine, cosine, and tangent, we just simply have to write the trig function. So the ratio here for sine would be opposite 7 over hypotenuse 25. Cosine, adjacent 24 over hypotenuse 25. And the tangent would be opposite 7 over adjacent 24. Now, to do the trig, the reciprocals, I do cosecant, I do secant, and I do cotangent. And so here, all I have to do is flip the ratio, and I will have my reciprocals. So there I've done all 6 trig functions. All right, so on this one, if I go to the left 5, 2, 3, 4, 5, down 6, 1, 2, 3, 4, 5, 6, and I put a dot, I'm going to come out from the origin. Always come out from the origin to make your terminal side. So that's the terminal side. Now, to create the other side of the triangle, we're always going vertically to the x-axis. So if I go vertically, that means I would have to go up. And because I'm going vertical, that's a right angle. And then theta will always touch the x-axis and the terminal side. So my triangle here would be -5, -6. So now if you can do the Pythagorean theorem, square both sides, add them up, you get 61. Well, the square root of 61 is not a nice number. And so this time when we do our trig functions, when I do sine, cosine, and tangent, this will be opposite -6 over the square root of 61. But we can't have the square root of 61 on the bottom. So I do a sneaky form of 1, which is square root of 61 over square root of 61. And now I have -6 times the square root of 61 over 61. Cosine would be the similar thing. It would be adjacent -5 over 61. Rationalize it, and I get -5 times the square root of 61 over 61. And then my last one is opposite for tangent, opposite over adjacent. And since they're both negative, I finish with 6/5. So the red numbers are my answers. Now, when I get ready to do the reciprocals, I do cosecant, secant, and cotangent. Now, if I flip the red number, I put the square root of 61 back on the bottom and I have to do a bunch of extra work. So let's go ahead and just flip the green number, and that's square root of 61 over 6, and it would be negative. For secant, I would flip the green number, square root of 61 over 5, negative, and the last one would be 5/6. So work smarter, not harder. Don't flip the red numbers, flip the green ones. All right, I'm going to do, I'll probably just do the first one. I'll do the first two, and then you can do the last DIY. But if we draw the ground, and I put a flagpole, and that flagpole is 12 meters, the sun would be up here, and this angle of elevation is what they want us to find. Now the shadow, make sure you put the shadow on the ground. The shadow's on the ground, and so that's a 17-meter shadow. So to solve this, I would do the tangent of theta, because that's going to use the opposite and the adjacent. So the opposite 12 over the adjacent 17. To get rid of tangents or any trig function, you do the inverse. So that's tangent to the -1, tangent to the -1. And so theta equals the inverse tangent of 12/17. Now remember, our calculator is already in degree mode. So when I solve this, I'm going to type in second tangent 12 divided by 17, and I get about 35 point, let's round to the second, so 35.22. So I get 35.22 degrees. This one, I draw a skateboard ramp. It's a right angle. It's 4 feet high, has an 18.4 degree rise. Now, the length of the skateboard is this side of the skateboard, or the skateboard ramp. And so this would be opposite over hypotenuse. So I'm going to do the sine of 18.4 is equal to opposite over hypotenuse. And again, you see the x on the bottom, so we would multiply by x to get rid of it. Now divide by the sine of 18.4 on both sides. And so on our calculator, we're going to do 4 divided by the sine of 18.4, and we're getting about 12.67 feet. So we're getting 12.67 feet. All right, the last one's a DIY, so you're going to try that one on your own. So pause the video now, come back and look at the answer. So here's the diagram. The ramp itself is 17.5. It's 3.5 feet high or off the ground. You're finding the angle of elevation, or the angle that it makes with the ground. So here's your trig formula, inverse sine both sides. You get 11.54 degrees.